But for now, I'd like to introduce to you our Silica expert who will be explaining all of this to you tonight. So Marcus Brooks is with Robson Environmental. Marcus is a senior occupational hygienist with over 12 years experience in the health, safety, environment and community space. His primary passion is to use his extensive technical ability and his experience to implement and deeply embed hygiene best practice into an organisation's culture by utilising his own enthusiasm for hygiene, health and safety. So I'll now hand you over to Marcus, who will be presenting tonight, and please welcome him with a round of applause.
Thank you very much, Peter. Well, that's a lot to live up to, so thank you very much for that. I think that was a nice way to say that I like to talk a lot and like to help people out by talking than wasting your time getting you to spend lots of money. Poor business consultant, great hygienist trying to make it better for you. All right, so as Pete said, we're here to talk about Silica. So there's been changes in the legislation, and this presentation funded by ACCI and the Australian Government or Department of Employment and Workplace Relations, always forget that one, is put some money aside to help small to medium businesses get more out of it. Understand what the changes in the legislation means. Again, all state and territories are different. I know that you'll probably have some Victoria-based ones, which might be a bit out of mind, but we'll see how we go, to make it easier for you to get onto the same page and the right page forward, and you're not wasting your time and effort. So it's been put together by them to hopefully make it a bit easier for your day-to-day jobs. So we're going to cover a lot of stuff. It's not a Silica awareness situation where I'm going to tell you everything about Silica, monitoring everything, but we will cover what Silica is, why we care, how it hurts you, and what the changes in legislation has come about, and how it can be easier for you to get through. There have been some PowerPoint presentations, there's been some flowcharts designed up from ACCI for what are not high risk. Legislation is all about high risk exposure, high risk work. There's some medium and low, which may be more beneficial to you, which ACCI are providing, which you should be able to get a hold of at any stage, which might make your job easier, but we'll talk about that and go through. As Pete said, I'm quite happy to answer questions on other parts that are in here that's related to Silica. I like to engage as we go. Instead of you sitting there just listening to me, it's about you, it's not about me. So if you have questions and it doesn't make sense, please ask. Otherwise, we can have some more questions at the end. Even if it's a little bit off topic, quite happy to use this time to make it informative and about you. Cool. So what are we talking about? We're talking about what crystalline silica is. So there's different types of silica. There's amorphous, and there's crystalline silica. And you need to know there's two different types. So amorphous silica is sand, opals, glass, it's in toothpaste, it's in rubber. The amorphous silica is not the stuff that's going to kill you. If sand as a silica product was going to kill you, we would have died out as a species millennia ago because we would have been exposed to lots of sand dust, our lungs would have been able to handle it and we would have passed on. We're concerned about the crystalline fraction of silica. So it's the one which causes the health effects. So we need to know there's two different types. We're going to talk about the different health risks and what it means to you, to your workers, and how being exposed to different types of silica and how much of it can affect your health. We're also going to talk about high-risk processing and what a crystalline silica substance is, which is what the changes in the legislation are. They've come up with new terminology. I love legislators. They come up with lovely new fun words all the time. They've got to have an acronym. It's a new thing in there. It's a crystalline silica substance, CSS. They've changed the legislation to you need to ensure that you've identified what it is and what you need to do. So that's what we're going to go through a bit later and what the changes in legislation are. Again, if there's a Victorian-based one that's a little different, I'll try and answer as best I can. If not, I'll come back with you some other answers afterwards. All right. So crystalline silica. So as I said, there's two types. It's naturally occurring, there's amorphous and crystalline. So together they're made by the same building blocks. It's a silicon molecule with carbons and oxygens attached to it, exactly the same except for amorphous silica. Think of it like spaghetti. It's all jumbled into there, it's the same structure, but it's not nicely bound. It's the one that doesn't really cause health effects. You need to be exposed to sand ground up to as fine as you can for hundreds of years, or maybe less, depending on how fine you grind it and how much you're exposed to day and day, to get the health risks. It's the crystalline version is the one we're concerned about. Same structure again, but it's in a lovely molecule. It's very sharp, it's very defined, it's very tight. So it's cutting that crystalline silica molecule up is what causes the problem. So when you cut a very structured quartz material like that up, it breaks up, it has nice sharp edges, nice sharp shards on it, and it has a different charge on it, which allows to affect your lungs differently, which we'll go through in a minute. So that's the one of concern. So where do we find them? We find crystalline silica in concrete, pavers, bricks. We can find it in clay. Clay is an odd one. Clay can have anywhere between trace amounts of crystalline silica up to 50%. So clay is one you need to think about. Do I really care? Do I need to do more? Do I need to work it out? Concrete, rocks, soil, all different types out there. There is crystalline silica in them. We're only concerned about a small fraction of that, which we're going to go through next, is different sizes. So you'll see terminologies of respirable crystalline silica or RCS. That's the very fine particles that we care about. We don't care about the large ones. It's an irritant. It's the small ones that are the health concerns to us in a business and as an employee. So we have different types of respirable crystalline silica, and I'm just going to call it RCS going forward to make it easier. So we have the large fractions. So let's break it up. So we have large inhalable particles, which we breathe in. It's the stuff and dust you can see. If I'm concrete cutting, are there any electricians in the room? One. Good. Okay, I won't pick on the electricians too much. So I don't want to pick on plumbers, because plumbers would all have a go at me, but electricians. So if an electrician is wall chasing and they're cutting into concrete wall to run some cables, there's dust going everywhere. That dust, they haven't put any controls in, not saying they're doing the wrong thing. The dust in there is the large particles we see inhalable. We breathe those in. They're usually about 100 microns in size. They're the stuff you can see in the air. It gets through our nose, it gets in our throat, and we have good processes in our bodies to allow us to let it sit there, cough it up, spit it up, and away it goes. Not a problem, more of an irritant. If I'm asthmatic, it's going to cause a little bit of an irritation. Not a health concern. Then we have the thoracic range, which are slightly smaller, anywhere between 30 microns to 100 microns. We can still see these particles, but they get further into our body. So they'll go down our trachea, down our windpipe, and they get stuck there. And our body's really, really good at defense. It has lots of things to get things out. So we have little hair cells inside, which we call cilia. The larger particles or the thoracic particles get in there. They get stuck in our hair cells or cilia. And it has this great process called a cilia motion, or like an escalator. It gets trapped, and it brings it back up to the top, and we cough it up, spit it out, get rid of it. Fantastic, body defense works really well. It's the respirable section, the fraction lower than 10 microns is the problem. Generally, we don't see RCS that's below 10 microns. It's so fine, we can't see it in the air. It's the stuff that gets down to our alveoli. If you remember our grade 8 biology, for me it's many, many years ago, it's the little ball sacks at the bottom of your lungs where all the air comes through and changes from your body to your blood vessels to give you oxygen and take out the carbon dioxide. RCS gets to those alveoli. If it's sharp, it gets in there. There's no hair cells in there. It can't remove it. So it uses mucuses and uses white blood cells to attack it to remove it, which is great. But because of the shape and fraction and size of the RCS, it busts these things, it breaks them up, it doesn't work very well. So therefore they stay attached in the alveoli, it builds up after a period of time, it starts to get scarring. You don't get good oxygen passing between your lungs to your body, so therefore you're not breathing as well. And then you get all the complications down the track of silicosis, coronary obstructive pulmonary disease, and such. So they're the ones we're really concerned about. Engineered stone's a little different. Where engineered stone is made up about 95% plus of pure RCS with resins and other products. We can see those dust clouds because it's only RCS, there's just so much of it in there. So we're breathing the nasty size fractions in at all times when we're dry cutting engineered stone. Cutting concrete, it's going to be everything in the whole fraction. But there's less content in concrete, so it's a less of an exposure risk for longer periods of time. So yeah, we're only concerned about the RCS, and that's what we had the media come out, and we had all the push with the legislators and the governments and ministers to fix engineered stone. I know someone mentioned earlier, but what about the rest of the work we do, which is concrete, bricks, pavers? We've missed that, so they've come up with changes in legislation to see, let's see what your process is, let's try and make it safer for you to do your work, let's risk assess in a form before we do it. And hopefully this makes sense by the end of it. If not, ask us and we can go through it. So, some examples of health risks. We have the fine particles getting into our lungs. This is a complicated silicosis. Is there a button here? Yes. This should be lovely and black. You shouldn't have all the white spots. White spots are the alveoli that have been scarred, not getting good oxygen passage through. So therefore, they're going to have difficulty breathing. Not very good. Could we do anything about it? No, not at the moment. There are treatments at, I think it's MAIOH, and I know UQ are doing testing in the hospitals where they do flushing of your lungs. That's pretty much what it is. They put 25 litres of saline through one lung, because your lung's like a sponge, and flush it out while you're awake. And then they do the other one. It removes some of the non-attached silica particles to try and reduce it, but it's not fixing the damage that's already done. I personally don't want to go down that track and have my lungs flushed out with 25 litres of saline each lung. That's going to be very uncomfortable, and you're awake for the whole time. But that is one treatment. The other one is a lung transplant, but good luck being on the transplant list for that. The other one's lung cancer. Again, it's scarring of the tissue, scarring of the membranes across. Chronic obstructive pulmonary disease, that's minor scarring. It's starting to reduce your airflow through. It's usually, we see the people with the oxygen bottles with the nose pieces. It's giving that little bit extra good oxygen to help them to breathe. Kidney disease, chronic kidney disease, so it can affect other organs and limbs. And autoimmune diseases like scleroderma, so it's the puffy hands there. Yes?
Is that the same as the meso cancer?
No. Mesothelioma from asbestos. So the chronic obstructive pulmonary disease, yes, it's a fibre or a particle. Theirs is a fibre, this is a particle, different terminology, different things, that scarred the alveoli, which is not allowing good oxygen transfer and carbon dioxide. But that's all mesothelioma is, and a lot worse down the track. So mesothelioma, you can't repair it like silicosis, but mesothelioma is designed around fibres from asbestos, silicosis is from RCS. Similar thing where it's affected the lungs where you can't fix it, yes. But they have different rates of infection, different rates of uptake, different rates of degradation, or when you your life expectancy as well. Accelerated silicosis was the ones we saw engineered stone benchtops, where short term, when they've had large exposures, I mean extreme exposures to lots of silica and RCS, short periods of time is when they've just really destroyed their lungs. Mesothelioma from Whitnoon in WA, same thing, the blue asbestos, which is beautiful, but the worst asbestos out. Same thing again. White asbestos, it takes longer. It depends on what it is and what your exposure is. So you could think of it the same way. You treat it the same way as in reducing your exposure to it. The respirators or your controls can be similar. But yes, it was something that was forgotten. But yes, it's also autoimmune diseases, weird other things that can happen. Puffing in the of your joints, it's just swollen. It's not just in your lungs, it gets everywhere. So it's poor oxygen flow to different areas, breaks down cells. It's not the best. All right. So that's a little bit on the health effects of silica. Does that make sense? Anybody want anything else differently? Any other questions?
The images you had up just before,
Yep.
What level of exposure have those lungs had to get to that point?
So complicated is usually anywhere between 5 and 10 years, depending on how much. If that was engineered stone, you would be a lot worse than that in a shorter period of time. Engineered stone where you're wearing controls part of the time, it's maybe what you see. So accelerated silicosis, acute silicosis is usually 1 to 3 years. This is probably 5 to 10, it can be a bit longer. Same for coating concrete where you get an RCS. It can be that long, it can be a bit longer, it can be up to 15 years. So this is someone who may not have worn any respiratory protection in the work environment, drilling holes into concrete, jackhammering, lots of exposure. Tunneling would probably be a bit quicker because tunneling is just full of dust in the air, which is nasty. But yes, you can get that in a, part of your workplace. And most people work, in the workforce? 40, 50 years, unfortunately. They keep us working forever. That's not far through your work life. And then it's going to affect your life going forward, what you can and can't do. So yes. And it's something we can prevent by having the right controls in place. So yes. The scleroderma depends on the person, depends on the exposure, depends on the frequency. So everyone's slightly different with their body makeup. That can be short. Generally, it's a longer period, 10, 15, 20 years, depending on the person. All right. So why am I here? It's about the changes in the legislation. So the government in 2024 said, let's try and fix some of the other problems. We've done engineered stone. What about the others? What about all the construction workers, the plumbers, the normal work that goes on that keeps the country running? We can't ban concrete. It's not going to happen. We can't ban bricks. We can't ban all the work we do. So let's have a look at how we can try and assess our exposure risk to these products for you as workers and for its PCBUs. So a PCBU has a requirement to ensure, as we all know, that minimise exposures as low as reasonably practicable to all workers, or if not, eliminate it. Can't eliminate concrete in our work, can't eliminate pavers that have silica in it. It's not going to happen. Sure, you can have some other stuff, but we generally have products in there that have silica in it that we need to be concerned of. So they can't eliminate it. We need to minimise our exposure as best as we can. And if we can't minimise it as much, we need to make sure our controls are effective and we're making sure our workers are monitored if we're unsure of our controls. So they've come up with how are we going to do this? So they said, let's have our lovely term, crystalline silica substance, or CSS. What does that mean? What do we say a crystalline silica substance is? Anywhere that has more than 1% RCS is determined by legislation in the model work health and safety regs. And again, I know Victoria hasn't adopted the model one, but in the model one, it's section 529A says, any more than 1% weight by weight is considered a crystalline silica substance. What does that mean to you? Probably not a lot. What's more than 1%? The best thing about that is we have friends. We have the internet. We can Google it. We can ask the manufacturer, what is it? We can ask our supplier, how much RCS content in is it? We could spend money if we're doing quarrying or mining or other things, and we want to know the composition. So we get the petrograph of the composition. This will tell me how much percentage of respirable crystalline silica is in there, so we can work out what the CSS content is. So when the labs do it, we can get a lab to do it. When a lab does it, they measure it and they're looking for alpha quartz and cristobalite, which are the two main ones for RCS. There's others called tripoli and trinamite. We can't measure them in Australia. I think the US are just starting to get onto it, but it's not practical. And it's a contamination that's very, very sporadic through normal quartz and silica materials. But as I said, you can get a lab to do it, spend thousands of dollars for doing it. Otherwise, Google it, ask a friend, or, as I'll show you in a minute, you can just assume that it's got RCS above 1%, and then let's work through our processes. So if you want to take that process of assuming it's got more than 1%, how do I go about meeting what I need to do by legislation? Engineered stone, it's a given that it's going to have more than 1%. All right. So all these products up here, bricks and mortar, asphalt, cement, sandstone, rocks, concrete, sintered stone, granite. They're all more than 1%. So I can save you thousands of dollars. Don't bother looking it up. It's more than 1%. When you do your assessments to work out what your work is and what your risk exposure is, if you're using any of these, you're drilling holes into concrete walls or ceilings, it's more than 1%. Concrete's usually anywhere between 20 and 40, depending on where you go and how it's made, depending on what the base metal is, how much blue metal, how much lime, where they got the lime from, it adds up. So if it's any of them, it's more than 1%. You're going to tick that box. As I said, clay is a little different. Clay can be anywhere between trace to 50%. That may be one for schools, which if you're using clay in schools, is that a risk to my schools? Is it a risk to my students and teachers? You'd probably want to assess that one, and you can get it tested. Problem is you can't have anybody here ever done any air monitoring for RCS in the workplace? Been made to wear the pump with the little tube to see what it is, what your exposure risk is?
I've worn one, but I don't know what the reading
Okay, so what it is, it's not much fun. It's a pump. They've got to draw air through it. It's a little filter. It captures what's in the air. They analyse how much is on there to work out a concentration, and then they can measure what is on that filter. So is it alpha quartz or is it just other stuff which is an irritant, not going to bother you? You can't use that to determine if you've got more than 1%. So the legislation is very clear here. You can't use your exposure monitoring results to say it's a CSS. You've got to actually work out what the composition is, not from your air monitoring. And another one was people concerned about, what about if I got something that's less than 1% and I'm cutting it up and it's in a small room and there's dust everywhere? Can I use that to say it's more, or can I say, oh, I've now got more than 1%, do I need to do things? No, it's what the original composition is. So yes, it is a concern from risk. If I've got something that's less than 1% and I'm making lots of dust in there, I'm going to increase the amount in the air. So it could be exposed to more than 1%. Let's look at my controls. But you don't have to, if you get that less than 1%, you can tick the box and move on and do your work as normally. You don't have to follow the new processes here.
Sorry, is it found in roof tiles?
Depends on what your roof tiles are made of.
Yeah.
I know it's a vague answer, but it does found in ceramics. So you've got, what else are your roof tiles made of? Terracotta. Terracotta is very low. Depends on where your terracottas are made. So you can have stuff into 2 to 5%. You can have stuff that's below. So again, as a practical point, if I'm cutting up, breaking a roof tile, terracotta tile with a hammer and chisel, large particles, I don't breathe in the large particles. If I take it to with a 5-inch grinder with a cutting disc on there, I'm putting the dust everywhere, I'm going to breathe some of those particles in. A lot lower concentration. It's going to take me a longer time to have health issues and get an exposure risk. And I may not even get an exposure risk. But yeah, so how you use it could determine what your exposure is to it. Cement ones are, yeah. And if it's Super 6, we know it's all asbestos, so we just move on from them. So, all right. Wait. Don't know what happened there. Let's go back. This is all right. So this is in the current workplace, working with crystalline silica by Safe Work Australia. It's in there. When you read it, some of it makes sense, some of it doesn't. So that's part of the reason we're here, to try and make it a bit easier. It says, are you processing a crystalline silica substance? Do you know? As defined under regulations 529A. So I don't know. I've just told you what some of the products are that could be RCS contained. They can be crystalline silica substances. They're more than 1%, so that could be a tick a box, yes. Or it could say, no, it's not. So, as I said with it, if you don't know, Google it, ask a friend, spend the money at a lab if you really want to, use the internet, ask somebody else, get the manufacturer to supply it if it's something imported. They now have to start giving you what's coming in importation as a silica component. And it shouldn't just say silica, it should say alpha quartz. And if it says alpha quartz above 1%, then it meets a crystalline silica substance. So if you've got a good supply from overseas, ask them to give you the extra. I know that's where they're pushing it from a legislative requirement too, for importation. So, am I processing one? So I've worked out I've got more than 1%. Now, am I going to process it? So this is part of our whole process that we have to work it out. 6 different things that are listed. If it's one of these, then it's a yes. So am I using power tools, mechanical equipment that is used to modify crystalline silica substance? So am I cutting concrete pavers? Crushing, cutting, grinding, trimming? Am I using a Dremel? Even a Dremel is listed in there. Am I polishing using brass and other sorts of compounds with different things? They may have it as well. Some of the compounds for polishing brass in the military have 20 to 30% RCS in them. So, and they're using little buffers to do it. So they're actually a process of crystalline silica substance. They're processing one. So I'm assuming by the work you do as plumbers, yours are going to be number 1 and maybe number 6. I don't think any of you are excavating using a road header. If you are, if there's work around there, that is a process defined in legislation. This is what it is. We have quarrying. As you'd expect, all quarries have lots of quartz, lots of material that are going to have more than 1%. Limestone is weird. It can have less than 1. It can have more than 1. Depends on where you get lime. So some quarries get away. If they've just got limestone, they've already got to that, they don't have to worry about the controls. Might bug the neighbours. That's an EPA problem, not a risk with RCS. Equipment used for screening, so your mechanical screening, your sieves, your rock crushers, all those. Tunnelling. If you walk into a tunnel or work in any tunnels and you can see a cloud of dust, personally, monitoring for it is not the way to go. If you've got a cloud of dust in a tunnel, there is so much silica being released, let's work on your controls and protecting you. So any tunnelling will generate a crystalline silica substance. And the other one, which is a catch-all for all those, the cleaners, the people doing the works at the end of the day, I'm using a sweeper to clean up my dust in the area. That's a problem because you've got all the higher content that you've just now ground up and released from the concrete. You've got lots of RCS on the floor, and now you're sweeping it up. You're capturing it up. If you've had a wet slurry and you've caught it all there and it's dried out, now you've got concentrated version. So this is to capture all of those where you could be exposed to. It can be as simple as removing your bags from your HEPA filtered dust extractor to dispose of it. That can be classed as a crystalline silica processing work, unfortunately. But you can risk the higher level or medium or low rating from it. So this is their catch-all. So as you can see, removing the dust there. Do I need to have any controls? And I'm not going to have that in a tight air-controlled room with a local exhaust ventilation to remove my dust bag from my vacuum cleaner. It's not practical and silly. Do I need to put a respirator on? Depends on what the mess is everywhere, maybe, while you're doing it. It all depends on what you're doing. Yes. Brooms. My thoughts on brooms. Someone asked about brooms before. Brooms should be banned. My personal thing is brooms should be banned at any construction site. They're great for Halloween. They're good for my mother-in-law. But they're great. They're not for thing. All you're doing is aerosolise. I've already told my mother-in-law. She was happy with it, so I won't get in trouble. All you're doing is re-aerosolising the concentration of the RCS that's been liberated out. One thing I forgot to mention is that RCS, if you're cutting it, it gets aerosolised. It's the stuff you can't see. If we did that wall there, I'm pretty sure it's gyprock, but if it's not, if it's concrete and we cut into the wall, there was no one here, the guy doing the person had a respirator on, we come in tomorrow and he's cleaned up his mess, we come in tomorrow, we'll still be breathing in RCS. We come in 2 days, we're still breathing what's left in the air. It's so fine and so light, it can stay aerosolised up to 72 hours. So it's just not your work you're doing, it's what you're leaving for the people following on. What you're leaving for the plasterers, the fit-out people. If you've done a poor job in your job, what have you left for them? Are they being exposed? Or if you're the ones coming after the electricians have gone and done a wholly lovely work and put all their cables through and no, they don't make messes, electricians. And then you've come in to do your part later and then you're breathing in the dust.
So what about disposal once you've collected it?
It can be put in any tip. So
it's still not prescribed waste, is it?
No. So that was raised I'm from the ACT, that was raised in the ACT, person that has a contract to take all building waste when it first came out last year, and they've gone, we're not taking any of it. So we had a lovely chat to them saying, if you're not taking any of the works, and these were not just a skip that's got everything tipped into it that's open, these were the 1 tonne bulk of bags, sealed up, all put away, they've done it very well, and they just want to dispose of it. I said, no, we're not taking it because it's all RCS, but there's no risk. We're not chopping it up and removing it. So a bit of common sense prevailed after a chat to them. Otherwise, they were canning all construction work in the ACT. No work would occur. They thought about it again. And yes, in a sealed container, in little bags, it's just general waste. So don't know if the Victorian government has a different takedown here for your waste. That'd be something you'd have to check up, but every other way, it's not regulated, it's just construction waste. Just don't have it free and ceremony. If it's bagged up, it's contained, it should be fine.
Is there a requirement to bag?
If it's in you wouldn't have it in a, not double bag like asbestos, but in like your vacuum bags, that and seal off the top, perfect. If you can't seal the top, put it in another bag, that is fine too.
So if you're saw cutting for a whole day, you've got slurry everywhere, you clean it up bigger, you put it into the skip.
Yep.
And that dries and then turns into...
That becomes a problem. How are you going to do it? So that might be, you have a chat with your waste retailer to see how they want to take it, because if you tip that skip out with all that concentrated dust is the problem. They may or may not take it. They may or may not say it's a regulated waste. If there's a way, it's going to be hard for those ones. If you can suck it up and keep it contained, not a problem. That's an issue, and everyone's different. It's not like you're dumping asbestos everywhere, because they can just bury asbestos, but this is for that one because it's such a fine dust, if you tip it out of the skip, it's going to go everywhere. So that's you can put emulsifiers with it, so that way it sort of looks not concrete, but you can add other products, so you can get it out, so it'll come out, so it's not aerosolizing as dust. It's a more solid product, and I know there was one in Queanbeyan, just from New South Wales next to ACT, that were doing that. Quite happy to take it. It's more of a solid state, not an issue. So they can do that. I just can't remember what they were using to make it more solid. It wasn't concrete though, or cement, sorry. All right. So when is it processing? So you've determined you've got high risk because you know you've got more than 1%. You've determined that it's a processing thing. The next part of the regulation says, 529B says, what do I need to do? Or sorry, what do you need to do as a PCBU? You need to make sure you isolate the area or the people from it. You suppress using dust or water. May not be possible if you've got high voltage electrical or if you've got products in there which can't get wet. So that might not be practical. Using local extraction ventilation, whether it's a small little wheel level one, probably won't work in a lot of places. On-tool extraction works fine. Again, the right on-tool extraction for the right tool will take a lot of it away. Some of those can take up to 90% of the dust away, which is great. Whether it's a design one or a retrofit, it should go to a vacuum extraction system, which is H-class, because that's 99% efficiency. Same asbestos, you can use M and H, but for a silica, they only want H, so the higher level filtration. Something like that in place. If you're still having issues, then you need to think about respiratory protection. You cannot go straight to respiratory protection. Yes?
You talked about M class and H class.
Yes.
So what is it? Is it M or is it H?
It's H, it's the higher of the two. So M class is it's about 99% efficiency, I think. H class is 99.9, so it's a little bit more efficient. So they want the high efficiency rate, which is, memory is the H class. That's what they wanted to. We were hoping it would be M class.
M class is still accepted nationally?
For asbestos, for silica, it says high efficiency. You could have to check with your local regulator if they want it. Some in Queensland are taking M.
It's still accepted.
There you go.
M class.
Yep.
Every state I'm aware of is still M class.
Yes. No, some are gone to H and they wanted H, and I know that's part of a new push with the new ones coming in. So they're saying use H, but yeah, I think M's still personally fine. But yes, it's per state and territory. It depends on what it is, unfortunately. So you've got to check with them. But if yours have got M, that's fantastic because you don't need to spend the $6,000 on the system. You can spend the lesser one, which is still 99% efficient anyway. Don't use the one from home. They just blow it straight back out the back end and off they go. I know the on-tool ones are great. The ones that are designed are fantastic. The retrofit ones are good too. Just make sure it fits for it. And if you can't do it, then you've got to use RPE. And this is the thing that's listed in the regulation that says, using RPE, so respiratory protection devices, you need to make sure it meets the Australian standard 1715, so fit tested. If you've got a beard, you can't be fit tested, you need to use positive pressure. If you don't have a beard, you've got to keep getting fit tested every year to make sure that you're protected and you're wearing it effectively and it's providing enough protection for your job. But you can't go straight to PPE. But you can use isolation and PPE, that's fine. So if you're working with me and I don't need you there and I can do the job by myself and I can put you out of the environment, perfectly fine. I've isolated him. It's only myself exposed now, making sure no one else is exposed. I can get away with wearing respiratory protection. So you can go to that. You don't have to have everything else. If it doesn't work, you should try for higher, then work your way down. All right. So you can after you've worked out more than 1%, is it a process? Yes. What do we need to do? Is it high risk or not? So this is the question. So as I said, the legislation talks about high risk. It doesn't talk about medium and low, but you can get that. I'll make sure if ACCI hasn't given it to Zane, I'll make sure we give it to you, which will help. It lists 6 different things you must do in the legislation. You also must record any assessment you do. So whether it's in a proper risk assessment or some sort of SWIM or some sort of risk register, yes, it's above 1%. Yes, it's a process. This is what it is, and these are the controls. You need to record it somewhere. What type of work are you undertaking? What are you doing? Are you cutting? Are you grinding? Are you generating dust? What forms of silica? If it's sand, great, move on, don't need to do too much more. What is the weight in the recording of it? What is the percentage? What are the hazards? What is the airborne concentration? Do I need to do airborne monitoring? It's always a good one. Legislation says you need to require to undertake personal exposure monitoring where you're unsure of a risk. As I said before, if you're in tunnelling and it's dust everywhere, there's a risk. You can do exposure monitoring, but I'm going to tell you now you're going to fail. I'd rather spend the time, money and effort to fixing the controls to make sure they're not exposing the workers and putting good controls to protect the workers in than doing exposure monitoring. So the legislation says you don't have to keep doing exposure monitoring if you know what the risk is. Again, that depends on your regulator and how they want to see that and interpret it. So they might say, nah, still want you to do it. That's your interaction with your regulator, how you get on and how you make that work for everybody. I can't influence that too much except for saying, make friends with your regulator and get them onto the right process and right journey with you to do the right thing. If there's been any air monitoring before, you need to note it down. If there's been any incidents, exposures, health concerns, they've all got to be captured as part of your records. This is what derives your exposure risk for, is it high? So must not take into account any admin controls or PPE when you're doing it. So it says in black and white, take everything out. We don't take the admin controls or PPE as part of it. If that's all you're using, you cannot use that. You've got to have some sort of other control, unfortunately, when you're making your assessment. It's not to say you don't use it, but it's only to make the assessment. All right, as I said earlier, collect all the information. You can do it from internet, flyers, ringing the business, phone a friend. Told you, you can look at this, it's one of those. It's going to be high risk. Ask someone in the trade, someone out there has probably done some work, but it's got to be based on the work you're doing. Same, if you're doing drilling holes into wall to put fixings in there, concrete in there, so you've got concrete walls, putting fixings in, ram set them in after you drilled all these holes, but you're doing yours in gyprock, you're still drilling holes, different processes, different material, different risks. You cannot use that to say it's the same. So it's got to be the same thing for what you're doing. It doesn't have to be the same location, it's just got to be the same type of work. So if someone else has done it for you and you can use it, use it. Don't reinvent the wheel. Natural stones are a little different. That's the one where you either got to get the supplier to tell you the content when they've supplied it, or you spend the thousands of dollars analysing at a lab. So what they do is they take a section of it, they grind it up in a hooded environment, so therefore they're not exposed. They aerosolise a lot of it and they capture on a filter to try and find out how much fractions is in there, as well as putting on an XRD to analyse it. So it's usually quite a few $1,000s. They do petrographs of it as well to try and get a good picture of it. But if you can get the supplier to do the work for you, we'll only buy from you if you give us what it is. It's going to save you time down the track. I don't know how much natural stone you do in your industry. What you use?
The same as crushed rock.
Yes, crushed rock's weird because it depends where you get it from, because every aggregate for crushed rock can be from different spots and they all have different concentrations.
So if you're working in a trench and you're standing in the trench and someone dumps a bucket full of crushed rock, you fill the trench full of dust.
Yep. So you're going to have lots of large particles in there, which are going to probably be the irritant, so not a big concern. You'll have the smaller ones, which will be there. Depends on how crushed it is. If it's a large aggregate, yes, you're going to get a little bit off. The amount of RCS liberated is going to be minor compared to if it's quite fine crushed rocks up, and then you're going to have more of it liberated. It depends how long you're in there and depends on what you're doing. But yes, if you can, dumping in a trench, do I need someone in the trench when doing it? No, take them, isolate them from the area, which would be great. But if they have to be in there, I would assume the rock, the aggregate where you got it from is above 1%. So yes, it will be a crystalline silica substance. It is high risk because it's already mentioned it's a process of it. So therefore you need to make sure the controls are there.
So that would also mean if we're bringing up trench dust compaction and we're using tools to bring up compaction to the what we require.
Dry compaction or mist and dry?
Well, it's a bit of both, but 9 times out of 10 you're not going to have enough mist or water on there to bring it up.
Okay.
Which means that you're going to have particles flying around.
Yes.
But if we're doing that, that means we'd be going down the respiratory path.
Yes.
So
I would be definitely to protect your workers' respiratory, but this is part of the thing where you'd look at it using this, but then use the extra one for medium and low. It'll tell you what sort of protection, how much it is. And that might be a one where you're unsure. Let's do some monitoring of the workers to see actually, is it a risk? Yes, it's dust, but it could be all large particles which are an irritant and not a concern whatsoever. So that'd be a perfect example. Let's do some personal exposure monitoring on the workers doing this task, not just once, but a few different times. If it all comes back as nothing's detected, then you'd put that in your assessments or your SWIMs or your risk registers going forward. For this work, we've done all this, we've investigated it, we know it's more than 1% based on what it is. We know it's a high process, but we've got lots of data that says it's not a risk, so therefore we're going to bring it back to low. A respirator is now only just for an irritant. We only use it if someone wants to use it. It may not be a mandatory requirement. It's not an exposure risk from RCS. So that'd be one where you could determine it that way more so than saying, let's just add everything with high levels of protection.
What about a gravel road? Standing on the road, the workers there, he's getting the tools out,
Yep.
drive past gravel road.
So gravel road, it sounds similar. It's also, think of where you are. A trench is confined. It's more, especially if it's 2 metres, you're in the trench, it's higher. Gravel road, it's open environment. Dilution is a solution, a large environment. It's a small particle. You're not going to breathe in that one particle that's in less than 10 microns, 1 micron that's going to come back. And it's not one particle that's an issue. It's lots of it all the time. So driving past gravel roads, driving on gravel roads with your windows down, the risk is negligible because it's so low. If they're blasting, there's lots of dust coming back from mines, yes, it's more. But for those ones, the risk is low. If you're standing there day in, day out, it might become a little bit irritated and a bit of a scratchy over 40, 50, 60 years. For that sort of period, it's more of a small amounts there. It could have in small amounts, but it's such a large open environment, you're not going to be exposed. It's about duration, frequency and concentration. The concentration is not going to be there. The duration maybe not be there and the frequency might not be there. Sort of makes sense? So yeah. It sounds similar, but I get the trench one, which is confined. And if I'm standing in a trench that's 2 metres and above my head, I can't get away from it. It's dust all around me. It's keeping the dust in the trench, where on a road, it's an open environment. Yes, I'll breathe some of it in, but it's so small. And because it's the larger stuff we see, the smaller stuff might not get to us because it is affected by wind movement. And if it's an open environment, it could blow away and you're not getting exposed to it. Sort of make sense?
Yeah.
Cool. Hopefully it makes...
Teach your employees how to do it.
That's a whole different class. I don't know how to do it that well. Getting them to see the exposure risk and see what the problems are is the best thing, but getting them on board and making it about them is always hard. I feel for you, that's hard to do. All right. So once we've collected all the information, again, this is all listed in the legislation. It's messy, that's why we're here. What sort of work am I doing? Am I cutting? Am I grinding? What am I doing? What is the age of the equipment I'm using? Is it something that's my skill saw or tool that my father gave me from the 1970s? Is it still going? Is it poor? Does it work? Is it something that's brand new? How long will it be done? I'm drilling 4 holes in a wall once every 4 months. That's it. Duration does matter. How long am I doing it for? Am I doing it for 8 hours a day, 12 hours a day, 2 minutes a month, 2 minutes a day? With the flow chart, it's breaking down like to 15 minutes less a day, could be low risk based on duration, frequency and what you're doing. So have a look at that. And how long between processes. And what are your skill levels of someone you're doing it as well? That's always a good one to think about. Does the person know what they're doing? Is it an apprentice that's brand new, that's never done anything, and then just get in there, I'm going to have a go at this, and they make an absolute mess thinking they're doing the right thing? Or is it a tradie that's been doing it for 30 years and they don't want to make the mess, they don't want to clean it up, so they've got it all going really well, so the exposure risk can be different. Again, not picking on apprentices, it's just that they're more likely to make a mess not knowing what they're doing. What type of power tools? How fast the process? Am I using a drill that's slow speed? Slow speed cutting is better than high speed cutting. So you're breaking up the larger particles, you're releasing less of the finer particles. It's the high speed cutting, high speed drilling, which is when it's getting to releasing the RCS component out. It's breaking up and getting those little fine particles out that we can't see that are the problem. It's not the large bits, it's not the hammer whacking on a bit of concrete, breaking it up. Jackhammer is different because it's really fast and repetitious, but a chisel chiseling on a little bit of concrete, a little bit of marble, is releasing large particles, not the finer ones. And if it does release finer ones, it's such a small amount. Yours has untooled dust extraction. Is it retrofitted or is it provided? How old is it, I said? And do you have any information? A lot of suppliers I've seen don't give really good information on how efficient their untooled extraction is. That's where you have a chat to your supplier. How good is it? Will it work? Will it do the job I need? Get them to provide that information to you. I'd like to say they all work very well, but I don't know as I haven't seen a lot of data on it. There are some good ones out there though. All right. So we've collected all the information. Do we need to do air monitoring? Do we need personal, static? Do we need to do any more? So personal monitoring, as I mentioned, is if we don't understand the risk, we will do personal monitoring. If we do understand the risk and we put a whole heap of controls in, and now we want to see if it's reduced our exposure risk, sure, that's when you'd go back and do it. Or if a regulator says we want you to do it anyway, then you have to do it. So great to monitor what your people are exposed to. Static or boundary monitoring are great to see also how well your controls are working. We put all these controls in place. I'm not going to worry about personal monitoring on my workers. I'm going to see how well the controls are working. Let's go and test that. I have a job on Friday doing that. So with stone cutting, which will be fun. So you can use static monitoring, but you can't use them as part of your exposure profile if the regulator asks you, unfortunately. It's just working how well your controls are. But it's really good information. Compensation claims, they're also good. So if you know lots of people in the industry, for example, you do your research, all the data that's captured for any workplace compensation claim is out there. You can look it up through a work cover or whatever the Victorian one is. And it'll say, in 2023, we had 2,000 plumbers exposed to high levels of silica. I'm making that up, but it'd have the data in there. This was the health exposure. This is what you need to do. They've done their they've done their duration, they've done their post-lung function test. We're finding we're increasing their exposure risk. We're causing more damage. That data would be captured, and then you can use that. Oh, it's only for the one task. The rest of the tasks are fine, but all the data is saying it's this task. Let's spend our time and effort fixing that task and making it better for us. So look at the task, not just the whole thing. Record it all down. If they don't give you this in the regulations, I know it was there to start with. I haven't gone back and checked to see if they pulled it, as they wanted to change it. But we have a copy, which I'll give to Zane. All of this is capturing all the information I'm talking about. Where it is, what I'm doing, is it above 1%, do I'm doing air monitoring? It's just a nice way to track it down. This is your recording information. This is what you put it aside and says, yes, I've done my due diligence as a PCBU. I've worked it out. These are my controls. Let's go forward and go from there. Don't need to do it every time you do it. Do it for the task you're doing or the product you're using, and then you've got it aside, move on, work on your controls. It's not a daily thing to do. It's only when you come a new process or a new task. It's quite simple to fill in. Again, if it's not there, I'll give it. Hopefully this one doesn't change down the track. So we use 50% of the exposure limit to work out if there's a health risk, anything below 50%, negligible risk. Between 50 and 100%, let's look at our controls. You could start having something coming up. Anything above your exposure limit is where you may start to see health impacts, depending on how far above it is. It's where you expect to see health impacts to the workers. That may or may not go down. Don't think Victoria adopted 0.02. I know they want to, but hopefully they don't. Because you can only measure at 0.02 something is the lowest amount you can measure to without devices. So it's very hard to measure at your limit, and it's not as accurate. So we've gone through everything. We've worked out what it is. We've gone through, yes, it's a process. Is it high risk? We've gone and had a chat about that. We've determined it's high risk. Now you as a PCBU need to do more. So you've captured your data. You need to come up with a silica control plan, whatever that is for your own business. We will have respirators, we'll have on-tool, we'll have water. We'll do these different tasks while we're doing it. Don't make it overcomplicated. You just need to have something. Provide silica training to workers. The legislation says it needs to be accredited. Don't know what you have in Victoria for accredited training. The question was asked a month ago when I was in Sydney. They don't use anything there yet. I know ACCI run one. Find someone that's good, someone that knows what they're talking about. I know there are more and more RTOs are taking it on, but get someone that understands the risk instead of someone who's doing it for another task and awareness course, so you understand. And again, poor business consultant. If you have any questions, ask Zane. If you want to know anything, I'm more than happy to answer stuff too. I'd rather people, as Peter said when he started, I like to talk and I like to give information out and help people. So if I can help you make your job and life easier, more than happy to do it. And I said, poor business consultant, I'm quite happy to do an email. That's not going to cost you anything at all, you know. It's quite happy to help. And I'm interstate, doesn't matter, email works. What else do we have here? Air monitoring if you need to do it as part of the regulations, and health monitoring. So you need to provide health monitoring to the workers. Based on your work, you need a pre-medical, which is a lung function test, which is the spirometry ones, where you blow into the tube to see what your lung function is. Depending on your level of risk, you'll need to do it at a frequency. It might be yearly, 2 yearly, 5 yearly, or just exit, depending on your profile of the task you're doing and what your work's come up with. If you were still doing engineered stone, you'd want to do it 6 months or annually. Certain requirements also require to have a chest X-ray, depending on your lung function test. They can be as simple as an X-ray, normal X-ray, or it could be a CT scan with a low dosage thing on it. It depends on what you are. So it's not mandating it, but it depends on what the doctor comes back and says you need to do this as part of it. But again, if you've risk assessed it and it comes back as medium or low, you may not need to do it as well. So as I said, immediate actions you need to take is ensure the exposure risk is minimised with a combination of the controls. What can I do? I've determined I've got a high-risk silica process. I've determined it's high risk to my workers. What else can I do to make it better? Remove the brooms from the work floor, cleaning up at the end of the day. Let's have some on-tool extraction instead of having a mess we've got to clean up with the street sweepers and wetting it down and click up the sorry. Let's get rid of most of that to start with. Now, if we had to clean anything, it's only a little bit. Let's look at different wet, dry vacuums or something different. The controls are listed in 529B. Conduct air monitoring if you're unsure. As I said, if you're only unsure, organise health monitoring. Silica control plan, swims. Don't write all your stuff from your silica control plan into a swim. A swim is about the task. The swim will be, what controls am I using? I've got a high-risk silica process. These are my controls. These are my on-tool extraction, my segregation, my training, my PPE, and go from there. Yes, Zane?
Just want to add to that. With the current structure that's here in Victoria, requirements as they are going through and in the midst of early stages of creating compliance codes or codes of practice for silica in construction, the silica control plan or RCS is or can be incorporated at this stage into the SWIMS document here in Victoria.
Oh,
they are okay with that.
That's good.
As long as it is actually a control to control that risk. All right, that's what they want to see. So they want to be able to control it. They could label it as contaminated atmosphere.
Yep.
As part of which they one of the 19 high-risk categories of construction. So that can and they will accept it or a standalone document.
Yep.
Which they do have templates on the WorkSafe site, which are very good template to be able to use for identification of high-risk silica task and actual control statement templates to work on.
That's good that Victoria are doing it and combining it. Makes it a little easier as long as it's readable. I know the other states and territories some of them don't want to do it. Everyone's different. No one wants to adopt the same thing. And I know there's more changes going through with SWAR and the legislators at the moment, so we'll see what comes out of that. But yeah, don't overcomplicate it. You need to make it usable so people who read it, and they should read a swim that's meaningful or your silica control plan, so they understand what they're doing. They don't want to feed through 70 pages of documents to find something and they're going to tune it after page 3. Make it so it's usable. That's my little bugbear with swims. They've got to be usable. Otherwise, they're not going to use them at all. You're not going to get any benefit from them. The national accredited training, again, you'd have to ask Zane if there's anything down here. I didn't get any impression there was anything in Victoria, or if you're required to do it, because Victoria, again, is slightly different. Reporting any air monitoring results to the regulator within 14 days of receiving where you've had an exceedance. So that one didn't go down very well. So, but if you're using it for control monitoring, you don't report the control monitoring. That's to see how your controls are. This is for personal monitoring. And this is not my out to say don't do any personal monitoring. Personal monitoring is still valid and very good. But if you're doing control monitoring, you don't have to report those to the regulator. That's about seeing how effective your controls are. Do I need to fix it? Is something going wrong? Or validating them. It's only personal. Yes. Cool. Any other questions? So there are documents there. The working with silica resources. So Safe Work Australia have one. Working with crystalline substances. Guidelines for the PCBUs. It does have some helpful things in it. It's only last year's. They're updating it again. There's a new one. There's been new amendments come out for 529C, which is in the amendments for fines and how to do different controls and health exposures. So have a look at it. They are getting better and better, noting that it's not just about engineered stone as a risk, it's about all construction products, all construction materials. They may eventually go to wood dust, as wood dust is an irritant, and wood dust, especially depending on what sort of woods you do, that can be a problem too, with the arsenic levels and the other things in there as well. So they are getting more and more proactive with our construction industries, which are exposed to lots of stuff day in, day out. Bad thing about engineering stones, realised and driven that we should do more across the board for all people that got exposed unwillingly or unknowingly. Yes. One other thing with engineered stone. You cannot install it, can't import it, cannot install it. Got to make sure that whatever you're doing doesn't create engineered stone. There have been a few people that are doing stuff and have accidentally created engineered stone by the definition. You can still work on it if you're doing something's broken, you need to fix it or modify it. That's a whole different sorts of controls and requirements around it, but that is still allowed. But you cannot, put new stuff in. You can fix stuff that's there. Yep, cool. Any questions? Yes.
I have questions. So if you define that as not high risk,
Yep.
They still said in there that you still have to control the risk.
Yep.
And after we have like all sort of engineering controls in place, like how do you define that the inherent risk is still there, that you have to provide your worker with the respirator?
So it's more about you've got more, say if you've got concrete, let's pick 40% concrete, it's a risk, we know it's a process of working on it is, it's a crystalline silica substance process, we know it's all those, it's high, we're going to determine it's high risk. We've got more than 1%. We know it's a processing for what we want to do is we want to drill holes in it. But our job for your company is that we drill holes into a wall. We do it 3 times every 6 months. It's about frequency, duration and exposure. So therefore yours would come down from, yes, you've still got all those inherent risks there, but how often you do it means you can have lower levels of controls because you're only exposing yourself to a very, very small amount for a very, very small duration. So you're to go from medium to low or one of those when you look at it. So yes, you can go to the full level of high controls, fantastic, but you can reduce yours down based on the exposure risk to the people. So that's where you get the medium low out. It's about what's the concentration, how much are you going to expose to, what's your duration, what's the frequency. Sort of make sense? Did it answer your question?
Like after all that, you can have dust extractor, you
Yep.
can have, on tools, extractors, but is that still safer to give your worker respirator in use?
Yes, you may have to give them a respirator, yeah. Yep.
Is that?
It's like a secondary guard process.
Yep.
So your first and foremost is obviously water suppression, dust extraction, and then you're backing it up with the likes of your RPE as a backup. It's a secondary guard process. So you're putting it on to make sure that there's no chance of them breathing anything.
Yeah, so none of the other controls, if they're going to fail, then you're still going to protect your workers. And it could be that for that control for a respirator you're wearing, could be as simple as a P2 disposable dust mask because you're such a low exposure risk, where if you're drilling concrete every day, all day, you would probably want P3, full face, PAPRs, depending on what your exposure content and list is. So therefore, you could go down lower because it's a smaller amount you're exposed to. Always go for the high level controls if you can, but that's where you can bring it down a little. Yes, no, didn't agree. No.
Or should we do maybe like in-person monitoring just to find what
Yes.
level of exposures
Yep.
before we decide if they need to wear respirators or not?
So if you're unsure, yes, definitely do personal exposure monitoring. I would still be protecting my workers while I'm doing it, and then if it comes back and it says that there's no risk, then you can reduce your level controls down, if that's the same task. But that's not doing it once or twice. That's doing it enough times, randomised over the course of the year, and then evaluating controls. You can't say, we did it twice, we had no exposures, great. It was 40 knot winds outside and that was keeping all the dust away. But now we're doing it inside, different task, same thing. What is my exposure risk? So you need to do those different things if you're unsure, or you want to go, I don't want to spend $2,500 or whatever it is for a PAPR. I want to see if I can use less of a personal protective equipment control. Let's see our exposure. Oh, it's coming back. We're not detecting any RCS. Fantastic. I can do a lower level control as Zane said, as a extra layer of protection, but I don't need to go out to the higher level ones, and I don't have to go and buy. Sure, I'd love to have PAPRs, which are positive pressure for all the workers, which are nice and cooling, but if you've got 40 workers, it's going to add up really quickly. Yes?
So if we read through tonight, how many states have adopted what you've told us about tonight?
Queensland, New South Wales, ACT, Northern Territory and South Australia. Tasmania, I can't remember. Victoria, I don't really know how much they've adopted because Victoria is slightly different. WA are same like Victoria. They've adopted it in principle. They're doing other things, but WA, because of the mining and the DERM, they do it to a different level. So they haven't adopted the Model 1, but they're doing something as good. Victoria, I'm unsure of. And Tasmania, I do not know about Tasmania. I haven't got to look that one up.
And then also with the whole crystalline silica, so if we take the engineered state,
Yep.
because again, we can't import it, we can't do anything like that,
Yep.
etc. In a construction area, how many fatalities or deaths have we had due to crystalline silica?
In construction, I don't have the figures on that. There's quite a lot in tunnelling, which is still part of construction, but that's a different process. Mining and quarrying, there's quite a few, don't know about deaths, but there's lots in there that have, especially in the coal, there's issues there with black lung. That's a still respirable fraction. But construction, you're definitely having certain health impacts. I do not know what the death rate is. Zane may.
So I'll answer that for you. The death rates have been undetermined because most of the cases that have been linked to it have died before diagnosis. So hence why the fact that they brought in these controls to make sure that we're starting to cut this off real quick before it becomes a damn sight worse. That's where they know that it's a problem. So control it. What are we going to do about it and how are we going to control it? So putting these steps in place, determining if it's a high level exposure or a lower level exposure, determine the difference of just having to do all the monitoring, all the assessments, or a simple thing as a querying RPE can use that secondary guard to make a difference. And as a business owner or management, it's in the best interest to look at it as you're doing it as a risk basis in the business to determine the level of exposure, the duration of exposure, how often. If you're chasing bathroom double brick walls every day, you're using the whole BA system because that's your level of exposure.
Yep, you could use supplied air. Yeah, even with high levels of protection. So if I was using a full face respirator with a P3 mask on it, depends on how much dust is. So I was chatting to Zane earlier that I did a little experiment for my grads to educate them about not cutting corners at the end of the day and how much risk and exposure I have. I had a tree, neighbour's tree was cutting my concrete up and looks like it was about to start wrecking my wall. So I cut 2 cuts either side of where the tree root was coming underneath there. Whole heap of personal monitoring, real-time videos, captured it all to use for training and to work out what my exposure is if I didn't use any wet process, which I didn't. I just got a 5-inch grinder with a concrete cutting disc on it and went to it, so I was covered in dust everywhere. I had a full phase P3 respirator on. When I worked out the math at the end of it, I'd already overloaded that, so I was probably breathing in some of that silica dust because there was that much in there. I was over 800 times the exposure standard for 9 minutes worth of, let's just quickly do the job at the end of the day, and that was the old exposure standard, which is 0.1. This is now 0.05, so 1,600 times the exposure limit for a small amount of work. That was more about educating to them how a small job with a 20 to 40% measured, it was that 28% silica in the concrete, in no controls, like you had a respirator on, no controls can give me such a high exposure. If I did that once in 3 years' time, sure, it's going to cough up a bit, I'm going to get rid of it, it's going to be a little bit of silica in my lungs, it's not going to cause any lung cancer, silicosis down the track. It won't cause any of those, scleroderma, COPD, because it's one exposure, high levels, short period of time. If I did it day in, day out, or if it's a work at the end of the day when the boss says, you packed up, can you go back and do that job, it's going to take you 5 minutes, is everyone going to get all the gear back out? It's when they do those jobs, when they don't get it back out, it's when they're going to increase their exposure. If they're doing it all the time, that's when that can creep in. So you've got to be aware that the right PPE is fitting for the right task. And are you assessing it? So there's actually good calculators out there that says if you're exposed to this much, if you do the exposure monitoring, how much and how long should I use that respirator for? Most respirators are particular design that when it starts to become harder to breathe, you swap the filters out and go back to a new one because it's now overloading it. If it's a gas one, every 6 months, but a particular one, when it becomes a bit more resistant to breathe, you swap them out, put a new one. That could be weeks, it could be daily, depends on the task and what you're doing. Do I need to go to a positive pressure respirator? Do I need to go to breathing apparatus? Do I need to go to supplied air? Depends on the task, any exposure risk is what you go to.
You touched on getting your staff tested.
Yep.
Health tested. So if you're a business, like a lot of these businesses will be small businesses that are having, job by job, it will vary dramatically in terms of the impact of, the conditions or the site or whatever it is. So if we've got existing staff, should all existing staff now be getting a baseline test? And then should that baseline test be done regardless, yearly, say? From a business owner point of view, by getting that test done, if you're not exposed that you see, but their conditions are changing, what impact does that have as a business owner?
Yeah, so with the change in legislation, it says if you've identified you've got a high-risk process, you're required to do a baseline test. So you must do it. I know that's a lovely, massive cost to business depending on your workers. I don't know what it's like in Victoria. South Australia providing that service free for small to medium businesses. New South Wales have the lung function, lung bus that goes around that's doing it, providing that service. I don't know what they have in Victoria. That might be something for to push to see, yes, we want to protect our workers as a PCBU. What can the government do to help us out? I'm not a politician, I don't know how that'll work, but it now says that if you've identified it, you need to do a baseline. Do I need to do it every year or annually, or every 2 or 3 years? That'll depend on what your task is, your level of exposure risk is, if you decide to do it annually, 2 years, or every 5 years, or pre and start and finish. So if it was a plasterer, they're doing gyprock only, I'll do it pre. There's highly unlikely they're going to have an exposure risk. There can be contaminants sometimes in the gyprock, so it's very low. It's putting dust everywhere, so their risk might be low. You can do personal exposure monitoring. You give them a baseline, and then it might be every 5 or when they leave the business, depending on whatever the content is. But yes, so there's a requirement to do by the legislation that says you have to do a baseline, which is a lung function test, a questionnaire with the doctor, which says what type of work you're doing, what you're doing. CT or X-ray are dependent on the doctor's advice. They're not all required. Some industries you're required to do at least a chest X-ray, but not all of them. It's only some. Does that answer your question?
Have you introduced spirometry testing for new employees, so to speak?
Yep.
Your existing workforce, would you be compelled to get all of them tested?
Yes, if you're doing all the same processing you do, your new employees and all your existing ones as well. Yes, they've been working for a week, 10 years, 20 years, at least you're going to get something from there. The spirometry will tell you how good their lung function is. It may not be from what you're doing. It might be because they smoke 3 packets a day and they work in the office. That's not going to be from the RCS component. That's from the smoking. But yes. Also, if it's an office worker and it's in a quarry, yes, I would. If it's an office worker in maybe this building, I don't know what the level of exposure would be for your training is, you might not decide to do it because their level of exposure is going to be negligible 99.9% of the time.
And do you have an obligation on leaving? So if you've got a staff member who leaves, is it the obligation on the owner to get a test to determine whether something happened during that period of employment? Or is it the obligation, where does that lie?
You'll have to check your own state and regulatory ones, but for example, New South Wales, it's employment and termination, so when they leave. If it's identified as especially if it's like a quarry, for an example, when they start, when they finish, they do have an obligation to do that.
At the end of the day, Mark, it'll be the same sort of response will be around the hearing test.
Yeah.
In the hearing test someone when they begin employment.
Yeah.
In the case of the hearing test, if it's second year, before they leave.
Yeah.
If it's longer than 12 months, this is the last one. That way, you are safeguarding yourself as an employer to make sure that you've got the facts.
Yeah.
Because if it comes up in 5 years' time, they've got something, they can track when it's the last test.
Yeah.
It's your last noisy employer, yeah?
Yep.
They'll go through and find out who didn't test.
Yep. And if
Are you saying an employer who is departing your business, that you should get them to do a spirometry test before they leave?
Yep.
yes,
You've been tested throughout the period of employment.
Yeah.
You need something to back up the fact that they're okay when they leave you.
We've got a case at the moment that's identical to that, where we had an employee leave 9 years ago, who's just presented a hearing test that overlaps their pre-employment one from when they first started with us, and the hearing tests are identical. We don't know what he's done work-wise. He's only with us for 4 months. We don't know what he did in that last 9 years, and yet we're the ones being sued for industrial investments.
so that's the thing. Oh, I know we're not doing hearing, but I can talk on that if you want. So yeah, pre and post hearing is fantastic for covering for that. It's also not just about covering the PCBU. It's ensuring that your workers aren't being overexposed and that they're doing the right thing. So you do your pre. If you're at a plant, you should be doing duration during the course of a 1-2 year, while they're noise exposed. So you have your pre, which is non-noise exposed, 16 hours of quiet time. You have your during your work, every 1, 2, 3, whatever your risk profile is, where you do the retest, and that's when they're exposed. They're out on the plant, you bring them in the crib room or wherever they're doing it, they do their noise exposed, and that way you can pick up any temporary threshold shifts, any changes. Why are we seeing a shift here? We've got all these things in there in your office. You've got PPE. I don't wear the hearing protection. That's a behavioural thing, so therefore you can identify that. That's not on the PCBU. It's trying to get them to do it, but that thing you're covering a little bit there, and then you do post to see if it's a drift. If you're doing every year and they're following everything and they're seeing a drop in a certain frequency, it might mean your hearing protection is not effective. Or they may need to be fit tested to make sure it fits their ear better. Or it might be, can we work on our controls? Because certain drops in different frequencies will determine how much you pay in fines too. It's very regulated that way. It's listed out how much drop in the frequencies depends on the minimum amount that you can be charged or the rates it is. So it's always good. Anything which is a exposure to a contaminant, whether it's hearing, chemicals, dust, pre, post, it's about making sure the work is safe during the course. It's also making sure that they don't become your problem if they go away and do something differently and they want to come back to you. Or when they're doing their assessments and they say, what do you do? As part of the questionnaire should be, what do you do on your days off? I ride quad bikes and I shoot guns and I do all these sorts of things. Great. What do you do? I work in the office next to a plant. So the noise exposure risk is not from the office, unless everyone's got ringing ears. It's from their out-of-office activities. So therefore, how about you fix that? So, and look at that, not just the workers one. So same thing for contaminants and hearing.
Can somebody invent an astronaut suit for employees? That covers hearing, breathing, aspirating miles. We're paying a fortune.
It's about getting them on and taking them on that fun journey to start with. Get everybody, you need to do this. It's about you protecting yourself so that way you can have a lovely, healthy, fun life, doing all the things, buying all the tools, having fun with your kids and grandkids. But it's very hard to do.
How do you compel an employee that where you haven't had an amicable relationship when they're leaving? How do you compel that person to go and do this barometry and or your theory test?
I can't answer that one, I don't know.
That's you can't force someone to do it, but what you're doing though is you're making that note in a file, all right? You've got the records to back it up prior to that, or up to that point, or wherever. You've got that as a record. You've got a behavioural file to show for it as well. You've got no alarm levels of anything of whatever's been tested. In your records up to a certain date. What else can you do? All right? You're within your means of what you can do and what your own controls. You're noting it down, documenting as big as you can. That's it. You can't leave it out of the document.
Engage with a lawyer.
After employment, it's hard. During employment, it's easier. So if they're currently employed and they don't want to do the thing, I used to work in mining, so you can expect a lot of people don't want to do all the monitoring. And they'd take the monitors and they'd throw them full at the back of the ute in a mine, lots of dust, fill it up, come back and they're well exposed and I can see the dust dripping off. That's not how the machine works. So you come back and say, great, guess what? You're all wearing full face respirators, you're doing this every day, and they're in a truck. I'm not doing that. Well, then let's do the thing right. Don't try and be the pain and not do what you're required to do. Otherwise, this is what we're going to make you do. It was all right in the mining, so I could enforce them to do the things they wanted to do, didn't want to do.
But asking the question, how can we do this job we're doing, and we do every day, and we've done it for years, how can we do it better, how can we do it safer, and if you're getting their buy-in, believe it or not, you might find a cheaper solution for business.
Yeah, ask them. They might have a great idea how to fix it or do different things. Don't rely on the aircon in your cabin to filter out the dust. Does it need positive pressure in a tunnel? Are your controls? Am I putting my windows up and down? It could be as simple as that. The guys are coming in, you see the cabins covered in dust. They don't put their windows up. So the aircon's not working. That's back. Let's fix the aircon. Let's put the right positive pressure. Let's fix the seals. Let's have an environment which is safe for them so they can work safely during the course of it. So look at our controls, not just we've got something, make sure your controls are working at all times. Always revisit them.
Is there an obligation there for contractors as well?
PCBU, it's underneath the PCBU. If that's part of your subcontractors, they can make them do it. And it might, I don't know, depends on how your contracts, whether they make the subcontractor do it or the PCBU enforces the subcontractor to do it. Depends how that's written. Cool. Anything else?
We might wrap it up at this point because there is an opportunity, obviously, to ask questions afterwards.